everyone, my name is Solar and this is Simplified Science by Sal. Today's session is about computational mechanics with a focus on uniaxial compression test of a lattice structure with FCC units. Okay, as always, first we set our work directory to the folder, to our desired folder, and after that we should save our CAE file, which is FCC Uniaxial, to the same folder. Okay, let's start by importing our modeled files. Firstly, I'm importing my bottom RAM, which is 0.1 millimeter in thickness, and also I'm going to import the other part of our model, which is our FCC Uniaxial. Okay, very nice. And after that I'm gonna import my upper RAM. Okay, let's move on to the property tab. This is a copper Uniaxial which we are going to simulate its mechanical behavior and mechanical analysis. So I'm gonna write here CU, add a description of pure CU. This part is optional, this part is optional too. Okay, add a density of 8.96. okay, and elastic properties. Okay, and the Poisson ratio. Also we need some plastic properties which we could extract from a standard tensile test of our material, which is 220. Please make this to consideration that your first plastic strain is always 0. Okay, everything's fine. Let's create sections with a solid type and homogeneous for the material CU and start assign our materials. It doesn't matter what material you're assigning to your upper and bottom RAM, because we are going to make these structures rigid bodies, so it's not important what material you're using for. Okay, our lattice structure, Uniaxial, section CU, and the bottom RAM. Okay, everything is set. Let's move to the assembly part. Okay, good. Okay, so we need 2 reference points, one for our upper RAM and one for our bottom RAM. Okay, and also we need to create 2 sets, which I'm going to explain you at the right place where we are going to use this. The first is a set FCC, which I'm going to choose my lattice structure for this set. Okay, the second part and the second set is set RP, or better to say set result, and we choose this for this RP reference point 1. Okay, we are done in our assembly part. Let's go to the step part. We are going to use dynamic explicit, and an algorithm is on, increments are default, and also we are going to apply mass scaling for our set FCC by this amount, because we need to lower the time of our analysis. Okay, everything is okay, and now we are going to create an history output for our set RP or set result to extract the results at the end of the test by using this history output. Everything is fine. Let's move to the interaction part. Okay, we are going to create a general contact for our explicit. Also, we go with all with itself because at this type of compression test, sometimes bodies could have contact with itself. So, and also we need to create a contact with the default setting. Actually, compression test is one of the simplest mechanical analysis you can do with Abaqus. Okay, now we need to create two rigid bodies. Firstly, we need to choose the body element, and also we need to choose a reference point. Okay, this part is rigid, and it would, okay, for the second ram everything is fine. Two upper and bottom ram are rigids, and also everything is set. Let's move to the load part. We are going to use symmetry type for our upper and bottom rams. Actually, for our bottom ram, sorry, we are going to make our bottom ram in caster. Okay, and also we are going to apply displacement mechanical boundary condition on our sorry, upper ram to have a proper test. I'm gonna go with -5 because we are in our explicit. We're using dynamic explicit. We need to create an amplitude with 0 and 0, and also 0 point, and also 1 for 0.1. Okay, let's choose the amplitude. Everything is fine. You can see the direction, which is toward -y. And okay, let's go to the mesh part. I usually mesh everything together. We need a fine mesh, which is good. Change the type of mesh controls to tetrahedron. Okay, and just let's check everything is cool. Okay, we should have an elements library of explicit and the family of 3D stresses. Okay, let's apply the mesh. Okay, let's check the number of meshes. Good. Okay, let's go to the job part. We are going to create a job FCC1. Continue. Okay, submit it and we see what happened. Okay, the analysis is finished. Let's see the results. Okay, very nice. Okay, let's see the feature edges. Okay, I hope you enjoy this simulation. You can ask your questions through email or my LinkedIn page. Good luck and